Have you ever received that 2 a.m. phone call? Hey, reflected power just spiked. And at that moment, there are only two possibilities. Either it's harmless icing on the antenna or something in your RF system is actively destroying it. The transmitter doesn't know the difference, and depending on how it's designed, well, it might not care. And that's where the industry is split into two very different camps. Let's start with the first one, the foldback camp. The philosophy says if reflected power goes up, reduce the forward power just enough to keep the transmitter on air. Transmitter stays running, the reflected power drops, and well, everyone feels okay. And on paper, that sounds reasonable. So far, so good? But here's the problem. The transmitter doesn't know why the reflection exists. And in best case scenario, it's antenna icing, a known seasonal temporary condition. But outside of icing, well, increased reflected power always means something is wrong with the RF path. A defective RF switch, a mistuned filter, a damaged rigid line component, and well, fullback systems, they don't ask questions. They simply continue pumping power into the system until something melts. And that's the risk. Let's take a look at the second camp, the switch off philosophy. This approach is built around protection first, the transmitter output, a directional coupler continuously measures reflected power. There are two thresholds, a warning level and a fault level. And when the reflected power exceeds the fault level, well, the transmitter shuts down and then it tests the system 3 times within 1 minute. If the reflection drops, the transmitter returns to air. And if high reflection persists, well, the transmitter stays off and displays a fault indication. The key difference is simple. If the problem is in the RF path, the transmitter does not continue to operate and damage components. And now, this is where a valid concern comes in, and it's worth addressing. Antenna icing does cause reflection. That's real-world broadcasting, and this is exactly why configurable protection matters. In Rohde and Schwarz transmitters, the reflected power error level can be set across a defined range. The error level determines the point at which the transmitter switches off. One very smart approach is using presets. Separate presets for summer and winter operation. That way you maximize protection against reflection caused by anything other than the antenna itself. What cannot be adjusted and should not be is allowing the transmitter to stay on indefinitely, because when reflection is caused by a failed switch, a mistuned filter, or arcing in the transmission line, staying on air isn't resilience, it's denial. So this really comes down to a choice. Do you want a transmitter that prioritizes being on air no matter what? Or one that prioritizes protecting your investment? Uptime matters, but so does knowing when not to transmit. Well, that wraps up another Blueprint to Broadcast episode, an engineering decision that protects your signal and your system. So whether it's reliability, efficiency, service, or support, Rohde and Schwarz transmitters are designed with the broadcaster in mind.